For more than 170 years, ice has been hiding a secret. Not the kind you find in a spy movie, but something quietly lurking right on its surface. Let's rewind to the mid-1800s. Michael Faraday. Yes, that Faraday, the legend behind electric fields, noticed something odd. Even when it was freezing out, the surface of ice didn't behave like a rock-solid block. Instead, it acted, well, almost liquid. Scientists called this weirdness premelting. Imagine a thin, slippery layer forming on ice long before it's meant to melt. Now here's the kicker. For generations, no one really knew what this layer was made of. At the atomic level, it was a total mystery. Until now. A team of researchers has just cracked it, and trust me, their methods are as cool as the ice itself. They brought together two superpowers of modern science: atomic force microscopy and machine learning. But hang on, what actually is premelting? Ice, as you probably know, melts at 0 degrees Celsius. But here's where it gets weird. Even way below that, the very surface of ice starts behaving differently. This is huge. That slippery layer is why you can glide on ice skates, why clouds form, and even why we can freeze biological samples without destroying them. But seeing this layer up close, not so easy. That's where atomic force microscopy, or AFM, comes in. Picture a needle so tiny it can feel the bumps made by single atoms. You drag it across a surface and it maps out the landscape atom by atom. Brilliant, right? But there's a problem. AFM is great for neat, tidy surfaces, not so much for messy, disordered ones. And guess what? That's exactly what pre-melted ice is: a chaotic jumble, not a perfect crystal. So the researchers got clever. They used machine learning, basically, teaching a computer to spot patterns in the chaos. They trained an AI with simulations to handle the real-world messiness, then fed it data from the actual microscope. And just like that, for the first time, scientists could see exactly what was happening on the surface of ice. Molecule by molecule. The results? Mind-blowing. Between -152 and -93 degrees Celsius, ice forms a strange, amorphous layer. The water molecules are still frozen, but they've lost their neat, orderly arrangement. They're disordered, but still stuck in place like frozen chaos. As things warm up, this layer starts to act more and more like a liquid, creating a bridge between solid ice and flowing water. So it's not just a slippery film. It's a whole new phase, not quite solid, not quite liquid, but something in between. For decades, scientists suspected it. Now they've finally seen it. But here's the best part. This new technique, combining AFM with machine learning, isn't just for ice. It could reveal hidden secrets in catalysts, advanced materials, or even biological surfaces. Anything that's too messy to study with old-school tools. So, after 170 years, one of physics' coldest mysteries is solved. Not by one breakthrough, but by human curiosity, clever technology, and a dash of AI. Just goes to show, even the simplest things like ice can still surprise us. If you love this little peek into the secret lives of everyday stuff, hit like, share, and subscribe, because sometimes the tiniest details hold the biggest discoveries.